On February 1st, 2026, on the runway of Chongqing Liangping Airport, an unfamiliar colossus completed its maiden flight. Thai's drone, named the Ray-Z MBOWYH-1000S, may just look like another black dot in the sky to the average person, but to aviation insiders, it is more like a depth charge dropped into a calm lake. Developed by the 11th Academy of China Aerospace, CINCE and Technologue Y Corpor ATI-ON. It is the world's first truly hybrid-powered high-thrust, unmanned transport aircraft. BAF or IT. When we talked about drones, they were either small delivery models or exorbitantly expensive military variants. But this time, the rules have changed. The timing of this maiden flight is remarkably subtle. 2026 is exactly the first year of China's 15 TSVEEARPLAN, where low-altitude economy is no longer an abstract concept but has been officially designated as a core engine for driving new productive forces. Just a few days before this aircraft took off, the Tianma 1000, developed by China North Ind, UST Re-S Grow Up Corpor, ATI-ON, also completed its test flight. The launch of 2-ton-class unmanned transport aircraft within a fortnight means that China has formed a twin-engine layout led by two giants: Aerospace Science and Technology and North Industries Group in the low-altitude freight race. Thais Lai Utispa, Tikula Lai Intrigue, Yuingji, China. AROSP ACINCE and Technologue Y has taken a path of cross-border integration, forcibly merging aviation and automotive technologies. BY contrast, nor TH Ind UST, Re-S Grow Up has focused relentlessly on adaptability to extreme environments. It is as if one is figuring out how to minimize delivery costs, while the other is mastering how to deliver goods to mountaintops where even monkeys cannot climb. Together, they have essentially pieced together the complete map of China's low-altitude freight sector. The profound significance of the RAI MBOWYH-1000S's success lies not in how high or far it can fly, but in its logic of dimensionality reduction strike. IT's high-power hybrid powertrain was jointly developed with a leading domestic new energy vehicle enterprise. THICE means that the drone industry, once a high-precision niche sector with low production volumes, has begun to leverage the mature supply chain of the automotive industry on a large scale. It is like going from only being able to buy hand-tailored suits to suddenly finding you can purchase the same tailored quality at unique low prices. THI's cost reduction is the real ticket for the low-altitude economy to truly enter ordinary people's lives. HYBRID PABUR is the true edim ens ion ali Thai red UCT ion star Ike. Man, why may wonder why we bother with hybrid power when we could just use pure electric or stick with fuel. The answer lies in a very real physical bottleneck. Traditional fuel-powered drones have long endurance but suffer from slow engine response and complex structures. Pure electric drones, while agile in takeoff and landing, have batteries with extremely low energy density. Trying to carry 1 ton of cargo over long distances would require a battery weighing nearly half a ton, making commercial use impossible. The Rainbow YH-1000S offers an ingenious solution combining the strengths of both approaches. SIMPLYPUT. Its total power is a combination of electricity generated by an internal combustion engine and instantaneous power supplied by a power battery pack. DURING, the most energy-intensive takeoff and climb phases, the battery pack delivers a massive current pulse, much like nitrous oxide acceleration in cars, compensating for the slow response of the internal combustion engine. This allows the aircraft to lift off in an extremely short distance. The direct result of this technology is a leap in takeoff and landing performance. Traditional Alton class transport aircraft can only land at general aviation airports with proper runways. But with this hybrid power system, the RAINBOWYH-1000S achieves ultra-short takeoff and landing. IT no longer relies on expensive aviation infrastructure and can land on temporary dirt roads after a disaster or slightly flat grassland. This low ground requirement pushes its application scenarios to the limit. Moreover, this hybrid logic delivers vastly different energy efficiency across different flight phases. Dual-engine cruising, the internal combustion engine operates steadily, at its most fuel-efficient condition, charging the battery with excess electricity or directly powering the motor. According to public data models, this method boosts energy utilization significantly compared to traditional piston engines. THIS in turn increases its effective payload and extends its range. This improvement is known in economics as a Pareto improvement, an overall enhancement without sacrificing performance in any aspect. More importantly, this system performs exceptionally well in plateau environments. As everyone knows, the higher the altitude, the thinner the air, and the more drastically an internal combustion engine's power drops. But the Rainbow YH1000SS battery compensation system can intervene at critical moments to make up for the power lost due to thin air. THIS means that freight routes that were once difficult to operate in places like Xizang and Qingga, I can now run regularly with these drones. Lev era Jingji Odd Omo TV Tech H No Log Y for AVATI on. We must talk about the secret weapon behind the Rainbow YH1000S, its cross-border innovation logic. IT is not just a product of aerospace research institutes, but a deep collaboration between the aviation and automotive industries. SUCH cooperation was almost unthinkable in the past, as aviation imposes incredibly stringent requirements on component anti-CO and ST and demands for weight reduction, high temperature resistance, and ultimate reliability. But by 2026, China's new energy vehicle industry chain has matured to an extraordinary degree. A direct consequence of this maturity is that many aviation-grade components once only handcrafted in laboratories can now be mass-produced on automotive component production lines. Meanwhile, of the battery modules, drive motors, and even tiny power semiconductors used in the RA MBOWYH1000S share the supply chain of new energy vehicles. This leads to an immediate and drastic drop in R&D and manufacturing costs. Previously, building a drone of this class cost tens of millions of yuan. Now, with the cost amortization from the automotive industry, the price has been cut by a factor of 10. THIS mindset of dimensionality reduction integration is the only way to break the commercialization bottleneck of civilian drones. You cannot sustain an independent supply chain with low production. Volume sit would drive delivery costs through the roof. Only by leveraging China's world-leading automotive industry chain to support the aviation industry can the low-altitude economy form a true closed loop. Many insiders regard this as a textbook case of the deep integration of technological and industrial innovation. THIS automotive thinking is evident in every aspect of the design. For example, the aircraft's wide-body cargo hold is not a random design but is specifically tailored to fit standard intermodal pallets. THIS means cargo unloaded from mini-trucks can be directly rolled into the drone without secondary unpacking. THIS modular interface. FORC, land and air intermodal transport has brought a qualitative leap in logistics efficiency, even in post-operation maintenance. The aircraft adopts an automotive logic. The powertrain is designed with a modular structure, meaning that at many remote second and third-tier general aviation airports, there is no need to hire specialized aerospace experts for repairs. As long as the ground team has a basic background in mechanical maintenance, they can replace the core power module like changing a car battery with the manufacturer's guidance. Low RING. The threshold for operational support is the key to making these steel giants truly accessible to thousands of households. A trillion-yuan scale low-altitude economy cannot be supported by just a few aircraft. IT requires a complete set of industrial assets that are as mature, low-cost, and easy to maintain as automobiles. The significance of the Risai MBOWYH1000S is that it proves this path is not only feasible but has already taken its first step. We in the aviation industry starts to reap the dividends of the automotive industry. The boom of the low-altitude economy is no longer a prediction but an unfolding reality. ANOTHER Master of EXTRME WILO. The RAS EMBOW drone is making a name for itself. Another steel giant quietly completed its coming-of-age ceremony in northwest China. This is the Tianma 1000, developed by AI's Henji Technolog. Y grow up under China Nor S in the UST RES grow up, Corpor ATI on. If the RES MBOW is the champion, OF cost performance through cross-border integration. The Tianma 1000 is a top special forces soldier designed exclusively for humanity. As forbidden zones. Around 2026年1月10日, it completed its maiden flight in a plateau area, raising the competition for ton-class unmanned transport aircraft to a new level. The design purpose of the Tianma 1000 is crystal clear: to deliver goods to places where roads are cut off, mountains are too high, and even eagles refuse to fly. IT's greatest feature is an almost obsessive adaptability to terrain. As everyone knows, Western China is crisscrossed by mountain ranges with unpredictable climates. Thin air and turbulent air currents are a nightmare for ordinary transport aircraft. But the Tianma 1000 has an astonishing service ceiling of 8,000 meters, a height that allows it to easily cross the Qinghai Tibet Platu and the Tianshan Mounta Inns, truly achieving flight on the roof of the world. What's more, this aircraft has immense lifting power. IT's maximum payload is a full 1 ton, equivalent to hoisting a small family car into the sky. Combined with its range of 1,800 kilometers, it can essentially establish an inter-provincial air express line. Most remarkably, it has almost no runway requirements. Many people assume a ton-class large aircraft needs a professional runway of 1 or 2 kilometers. But the Tianma 1000 can take off with a taxiing distance of less than 200 meters. This means it can take off and land on grasslands, hard dirt roads, or even uncompleted highways in many remote mountainous areas. This versatility makes it the ultimate solution to the last 100 kilometers of transport challenges. Its most stunning technology is its optically guided landing system. The knack of it as giving the drone a pair of eyes that can see through mist and fog. In rainy, snowy, foggy, or heavily hazy weather, traditional visual landing is almost suicidal. But this system allows the drone to accurately locate landing points, even in extremely low visibility, a life-saving capability in emergency rescue missions. When disaster-hit areas face road blockages and helicopter access is impossible, the Tianma 1000 can brave severe weather to deliver emergency supplies precisely to victims. This all-weather, all-terrain, operational capability is the hardest core strength of Chinese manufacturing. This twin-engine layout reflects China's holistic vision for Halo W altitude economy. With just conducting R&D in laboratories, but truly has the ability to deploy unmanned transport aircraft on a large scale in various complex real-world scenarios. Feeling the DP gap S in the logist ICS Chai. If we look beyond technical parameters to how these steel giants will change Chinese people's lives, we find that an efficiency gap known as the air interval is being rapidly closed. The current logistics system has an awkward blind spot. Long-distance transport relies on large aircraft, high-speed, rail and ships with high efficiency, and last-mile delivery uses couriers and small drones with decent flow-shibility. Problem lies in the middle feeder transport link. Take, for example, transporting high-value agricultural products from the deep mountains of Sichuan to Shanghai. Pre-Vio USLY, the process required mini-trucks to wind through mountain roads for more than 20 hours to reach a distribution center in a central city. Before the goods were loaded onto large aircraft or trucks, Thai's process was not only slow but also incurred staggering losses. Now, however, drones like the RMBOWYH-1000S and Tianma-1000 have entered the fray, cutting the arduous mountain road journey that once took a full day and night down to a straight-line flight of just an hour and a half. Thai-S is not a marginal improvement, but a qualitative leap in efficiency. The establishment of such air express lines means that highly time-sensitive goods such as freshly picked mats you take or urgently needed medical surgical supplies can be delivered directly across provinces like same-city couriers. These drones are like flying trucks. They do not need rest nor expensive pilots and can shuttle ceaselessly within a radius of hundreds of kilometers as long as they receive coordinates and instructions. Moreover, the maturity of this feeder logistics is reshaping the geographical distribution of many industries. Previous USLY factories or agricultural bases had to be built near convenient national highways. Now, as long as there is a flat open space for drone takeoff and landing, even in the deepest mountains and forests, businesses can connect to the global logistics network. This breaking of spatial constraints will bring earth-shaking changes to the social and economic development of many remote areas, making resource flow no longer bound by geographical environment, but by the density of network coverage. China also has to consider the real issue of low-altitude logistics costs. The past, air transport was considered too expensive due to high aircraft manufacturing and operational costs. But as mentioned earlier, the deep integration of aerospace technology with the automotive supply chain is driving a sharp drop in aircraft manufacturing and maintenance costs. And the per-kilometer transport cost falls to an acceptable level for ordinary people. The low-altitude economy will transform from a laboratory exhibit into a widespread reality. Thai's process from quantitative change to qualitative change is exactly the industrial restructuring China is experiencing in 2026. ITISALSOTHELIFESAVINGLASTMILE Bay-owned cargo delivery. These Tong-class drones may hold even greater value in emergency rescue than in commercial applications. As everyone knows, ground transportation often grinds to a complete halt after earthquakes or large-scale floods. At such times, the delivery of relief supplies and the evacuation of the injured depend on the golden rescue window of just a few hours. What you just saw is merely a fragment of the truth. Welcome to the Da Vinci Matrix, the ultimate operette in system for the superior in the EVI Dual. We are decoding the world, one algorithm at a time. Click left to rewire your brain. Click right to witness the future. Don't be a spectator. Join the fleet. Subscribe now before the AI takes over.